Okay, talking about how we find a second derivative implicitly, and we're back. So given this, find this right here, which is actually y double prime, the second derivative. Okay. So let's just go ahead and find the first derivative, and then we'll talk about what this could mean. So I got 2x plus 2y dy dx equals 25. I'm fine with that. Oh, sorry, equals 0 before I do something silly. Yeah. So 2y dy dx equals negative 2x. So dy dx is equal to negative x over y. So far, so good. I like that, but I've got to take it to the next level. So let's go ahead and use our rules here, and maybe we'll use the quotient rule to take the derivative of this. So this is y, right? This is y prime. So y double prime, which is dy squared, d squared y dx will be equal to derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. So far, so good. I'm going to start plugging some values in. I know what this is, right? I know this is negative x over y. It's negative x, over y. So I have this is equal to negative y plus, it should be minus now. Minus x squared over y divided by y squared. That's not bad. And if we're dividing by y squared, well, what's that mean for us? I guess it means that this is equal to negative 1 over y minus x squared over y cubed, right? And that's not too bad. The other thing we can do is we can kind of plug in for y, and we'll do that now. Okay, so we know dy dx is negative x over y, so we put in negative x over y right here, giving us negative x squared over y right here, and we simplify out. So this is d squared y dx. This is the second derivative implicitly. And let's see what else we can do with this. Do we know what y is equal to? We do. We know that y squared is equal to 25 minus x squared. So we know that y is equal to the square root of 25 minus x squared. So that's helpful. That's what y is equal to. The square root of 25 minus x squared. So in some sense we could say, right here we have negative y squared over y cubed. I'm finding a common denominator here, by the way. Minus x squared, right? And then we know that this right here is square root of that, so that's just going to be that squared, so y squared is 25 minus x squared. So it's negative 25. Now it's plus x squared minus x squared over, and it's y to the third, so what's that going to be? That's really going to be this to the 3 halves, right? So it's going to be 25 minus x squared, 25 minus x squared, root 25 minus x squared. And this is kind of its own thing. This is canceling. So we have negative 25 over And if we're all now in terms of x, I'm just going to go ahead and write this as 25 minus x squared to the 3/2. And that's d squared y dx. So you'll see, we'll talk as time goes on about expectations here. Like, you could also write this as negative 25 over, right? And y was the square root of this, so it's really over y cubed. So we want to understand which form we're looking for sometimes. And yeah, this is y double prime, and so is this. So you kind of want to simplify it, and we'll talk about when you want to replace, when you don't want to replace. Let's just try to see if we can get the concept for now, which is at least right here, to take dy dx, which what you're going to find. And when you take your second derivative and you get it again, right, plug back in. So that's the trick here to getting this. And once we're at this point, we're doing okay, and then we're kind of being picky or nitpicking after that as to what kind of form we want. Some of this is simplification, but some of this is really like, what form are you going to want this to be in depending on your equation. So it's important to see that there can be substitutions here. We can have it all in x's, we can have it all in y's, because we have an equation that relates x to y. But that's kind of the end of that. And we'll leave it there for today. Okay, everybody. This video is kind of looking forward to tonight's assignment or today's classwork assignment, but it's also handling kind of chain rules happening here and implicit, and we get a product rule with implicit. So it's kind of like covering all of that stuff that we're not loving right now, I'm sure, but we need practice with. So let's find the slope of the tangent line, and I just kind of highlighted that the slope of the tangent line is dy dx. The tiny change in y, the tiny change in x, right, as the kind of the limit goes to 0 of that little slope there. And we want it at the point 3,1, so we'll use that, but we won't use that yet because we got to find dy dx. So let's go ahead and use our general power rule. We get 6, the function, as is, to the first power. I'm not going to write that. Times, the chain rule says to use the derivative here, so I'm going to do 2x plus 2y, but here the mismatch causes dy dx. I'm hoping we're understanding that concept at this point. Is equal to, I'm going to pull the constant kind of out, and then I'm going to think derivative of the first times the second plus derivative of the second times the first. And I change the order here a little bit. Take a moment, pause the video, whatever you got to do to figure that out if that doesn't make sense. Okay, so we now have everything we need to go about getting dy dx. It's just a matter of, you know, what do we do? How do we get there? So I'm seeing a couple things that are like kind of just cleaning up numbers real quick. If you see right here these 2's, and this is a 6 here. What if we, just real quick, instead we divide it by 2 here, so let's say we're dividing by 2 here, so that's going to become a 3, okay, and then if we're going to divide by 2 there, why don't we actually also divide by 2 here, okay, but notice that because I'm dividing by 2, twice, I'm really dividing by 4, and if I had factored out the 2, and I'd have a 12 here, right, and I'm dividing by 4 to get a 3 now. Does that kind of make sense? Hopefully it does. Again, we can pause the video, you can talk to your classmates in a moment if you don't understand that. So I really divided by 2 twice because I did it on 2 different multiplication problems. If I had factored this out, I would have had 12 here, and I divided by 4 basically to get 3. Divided by 2 twice. So dividing by 4 gives you 25y plus 25x dy dx. Okay? Now we've kind of gotten to a point where we just need to really just find dy dx. So at that point I'm going to, yellow might not be the smartest color, but hopefully it shows up a little bit. On my screen it looks good. I don't know how it looks on the projector. That's what I want alone. So, geez, looks like we have 3, oops, I'm not going to do that. Looks like we now have 3x squared plus 3y squared, right? And I got to multiply that by x plus y dy dx. And that's going to be a little FOIL there, equals 25y plus 25x dy dx. And I could call that y prime if I wanted to save myself a little bit, but I don't know. I haven't gone about doing that. So let's see where we go from here. Getting dy dx alone might be a nice thing to do. So we're going to do our FOIL here. We're going to have 3x cubed plus 3x squared y dy dx plus 3y squared x plus 3y cubed dy dx. That's a cubed dy dx still, equals 25y plus 25 dy dx. And again, we could shorthand that by just putting it as y prime. So now I'm here, and actually, if it's okay, I'm going to go here. Okay, not too bad. So we have to minus the 3x cubed here and here. We have to minus the 3y squared x. And we have to minus the 25 dy dx. So minus 25 dy dx plus 3x squared y dy dx plus 3y cubed dy dx equals 25y minus 3x cubed minus 3y squared x. Hopefully no mistakes. I caught a mistake earlier, and that's why your video is skipping a little bit. Okay, let's factor this all out. So it's dy dx multiplied by negative 25 plus 3x squared y plus 3y cubed is equal to 25y minus 3x cubed minus 3y squared x. Dividing by that term on the left side to get dy dx alone leaves us with the following. So that's gone now. And let's see where we can go with that. Oops. Of my ways here. This right here should be here, here, should be here, should be here, so it should be here, giving us a 3 here. Well, I'll change a little bit. You can see what I did there. Stupid little mistake, but a mistake just the same. So let's make those adjustments. So that's going to be negative 75 instead. Let's see what that does for us. Looking like negative 45 here on the bottom. I'm going to say it's 30 minus 75. And then here we have, let's see, we got 25 minus 81 minus 9. So 25 minus 90, and that should be, I believe, 65 negative, which reduces to 13 if you divide by 5 over 9. And that's finally the right answer. I went through this a few times, a little frustrating, but finally I got there. Hopefully my edits make it not too confusing. So slope of the tangent line at that point is 13, 9.